subtract 1, it becomes 3, which is 3 times 1. If you multiply 3 times 2, it becomes 6, and you added 1 here. Yeah, and then you do that for this one too. So
sorry, it cut out for a second. Would you be able to repeat what you said?
Okay,
Sorry about that.
So you see this first one?
Yeah?
It's 3 times 1 is 3, and then add 1, it becomes 4. And then 3 times 2, it becomes 6, and then you add 1, it becomes 7. There's 3 times 3, 9, add 1, 10. So,
yeah.
and then I done 30 times 10. Yeah, it's going to be 31 because you add 1 and
exactly right.
2.
Yeah, so we said instead of n, you put 10 because you know, so we were interested in 32. We know that 3 times 10 plus 1 is very, very close to 32, 31. So we know that 31 is in the sequence because that's going to be the 10th term. As you said, it's the 3 times tables plus 1, isn't it?
Yeah.
So it's shifted the 3 times tables by 1. So 31 is in the sequence, and if 31 is in the sequence, well, then 32 can't be because we know our term-to-term rule is add 3.
Yes.
Okay, awesome. So if we want to find where our term is, we can find it by finding the value of n on our nth term expression.
Yes.
Okay, let's have a look at a second example. So this time we're going to write it without the sequence. We're just going to go straight for the term to term. So we'll do 5n minus 2. And I want to check if 23 is in the sequence. Let's write that properly. So I'm going to write this as if you were getting an exam question. So is 23 in this sequence? That's kind of what we would be asked.
Okay, so...
Yeah, exam question.
No, because 5 times 4 is going to be 20. Yes?
Yeah, 5 times 4, yeah?
Yeah.
Is 20, yeah? And then minus 2 is?
And is 18.
18, yeah. So the fourth term is 18.
Yeah.
Now what do we do?
Add 1.
No, add 1.
That's the fourth term, and then add 5. Yeah? Is because you add 5, and then it becomes 23.
Yeah, 23. Okay, so which term is 23?
Fifth term.
Yeah, perfect. So 23, is 23 going to be in the sequence?
Yes.
Yes, it's going to be the 5th term, isn't it?
Yeah.
Okay, good. Awesome. So we know that 23 is the 5th term of our sequence.
Yeah, and you can, and also...
You
can do 5 times 5, 25, subtract 2, 24.
Yeah. 5 times 5, subtract 2 is 23. So what we can actually do, so these are, what about, is 71 in the sequence? So try working backwards. So we know that this thing here, so 5n minus 2, if 71 is in the sequence, it has to be equal to 71, doesn't it?
Yeah.
Yeah? Can you see it? So if you just scroll down a tiny bit, just underneath where written is 71. Yeah?
71. Yes, it is.
How can we check? So try solving this equation here.
Okay, sure.
So if it is in the sequence, then we'll get a nice value of n, won't we? Yeah? So we'll know that if 71 is in the sequence, then 5n minus 2 equal to 71 will give us a nice value of n, as we have with this one here. So 5 times n minus 2 was equal to 23, so n was equal to 5. So we were able to solve this previous one quite nicely. We got a nice value of n for it. With this one, we need to do the same thing. We need to find what is n when the sequence is equal to 71.
So, so n, okay, I know. So 71, it's 5 times n minus 2 equals 23, equals 5. So, okay, yes, so I know. So if 5, okay, so 5 times, it's not, because you see this one, this 23, yes?
Mm-hmm.
It's, if you do 5 times 5, 25, then subtract 2, it's going to be 23. But if you do this, you can do, 1 second, 75. So I can just check.
Mm-hmm. Yeah.
5. It's going to be 15, yes?
Yeah, good.
15 times 5. Multiply 15 and 5 together, and then subtract 2, it will be 73.
Yeah, perfect. So we know that the term-to-term rule is add 5. If 73 in the sequence, then there's no way for 71 to be in the sequence, right?
Yeah.
So we have 5 times 15 minus 2 equal to 73. And we can't get from 73 to 71 by adding or taking away 5, right? There's no way to do that. So great. Yeah, well done. So 5 times 15 minus 2. So what we're looking for here is we're looking for the terms that we know, and then we compare them with the ones that we don't know. Okay, so in this case, 71 is not in the sequence.
Yes.
Another way to see this, so let's have a quick other look at this. So trying to solve this equation, so 5n minus 2 equal to 71, then we do 5n equal to 73. And what can you say about the equation of 5n equal to 73? Would it give you a nice answer?
Let's see. So let me scroll down.
Yeah, so right at the last one.
5n equals to 73. 5n minus 2 equals 71. No, it will not.
Exactly right. It won't give us a nice answer.
Yeah, it will go over or under. Because it won't, because 5 cannot fit into 70.
Yeah, exactly right. 5 can't go into 73. So n is equal to 73 divided by 5. And that's not going to be a whole number.
Yes.
Okay? And we know when we're looking at sequences, we're only really interested in those whole numbers, aren't we?
Yes.
We don't really look at any kind of fraction numbers. Okay, so because n equal to 73 divided by 5 doesn't give us a whole number answer, then that's not going to be in the sequence.
Yes.
Okay, let's do, I think probably the last example we'll have a look at. So we'll do 6n minus 7. It's a little bit of a tricky one. Let's see if 33 is in the sequence.
Okay, so
Focus properly. Is 33 in the sequence?
okay, so 36. No, it's not, because so let's do this. Okay, so 6 times 6 is 36, yes? Yes?
Yeah.
36. Subtract 7, it will go below 33. So, yeah, subtract 7.
Which is?
It's 29.
Yeah, 29. But what is the next term? Maybe could be 33?
Yes?
How do we check?
So 6 times 7 is 42. No, it's going to be 35.
Yeah, so it's 35. So we know 29 is in the sequence. We know 35 is in the sequence. So therefore 33 can't be in the sequence because we've missed it out from our sequence.
Yes.
Okay, good. Let's try a little bit of a tricky one. Is 593 in the sequence?
Okay, let me see. Okay, so let's first not include this 5, but the 500 and just do it in the 93.
So that would be really good, but the problem is that 6 doesn't divide 100, so we need to make sure we do the whole number.
Okay, so
If it was maybe something like 4n, then that would be okay, but because 6 doesn't divide 100, then we can't do that. So you need to do the whole 593.
okay.
So try looking at it this way, so try this. So 6n minus 7 equal to 593. See if you can solve it that way.
It won't go in the because so. Let me just write this
So
down.
try solving that equation that we've written up there.
Yeah, and let me. Okay, so you see here, it's 593. Yes. If you add a 7, it will be 598.
Not quite.
No, 569. No, just 5. No, 600.
Yeah, 600. So we added 7 on both sides and we got 6n equal to 600. What's n going to be equal to?
600. How we don't know what it is.
So we're trying to find what n is, isn't it? Sorry. We're trying to find what is n equal to.
Okay.
Okay. So we're saying that the term, so the nth term, 6n minus 7 is equal to 593. Let's see if we can use that to find what n is equal to.
Yes.
Okay.
7. Okay, so if we do subtract this, so subtract this 7. Yes.
Yeah. So we added 7.
Yeah.
So remember, it's because it's moving from side to side. Yeah. Good. Add 7. And then we have 6n equal to 600. What does that tell us about n?
6n equals 700. So it's going to be 10.
Not 10, not quite.
No, you said 6n equals 700. So 100.
So 6n equals 600. So we can see this line.
100?
Yeah, perfect. So we're dividing by 6 on both sides, and we get n equal to 100. So if the term is equal to 593, n is going to be equal to 100, like we said here. Okay, good. Well done. Is that all kind of made sense? Is it a little bit clearer about what the nth term is?
Yes.
So one of the main reasons we use the nth term is so that we can check whether something is in our sequence or not. So if our value is in our sequence, then we can include it. Then we can find where in the sequence it is. If it's not in the sequence, then we won't be able to find where it's in the sequence.
Yes.
Okay, awesome. So that's everything for today. We'll maybe carry on practicing some of these for next time as well. Are there any topics that you are kind of going through in your book at the moment that we need to go through?
I just, because this sequence is 1, I might need a bit more.
Okay. Yeah, no worries. It's definitely quite a tricky topic, so don't worry.
Yeah.
Okay, perfect. Great. Have a lovely week, and I'll see you next time.
Thank
Okay,
you,
bye.
too.
Thank
Bye.
you.